Friends, we have discussed in the last class that unlike a normal system, real-time system is something different, and they are the systems which produce correct responses within a definite time limit. Remember, real-time system is the system in which we need correct output. Not only correct output is important, that correct output should be produced in certain amount of time, which is called time constraint or time deadline, and that time limit at which the system has to respond, it is real. What is meant by real? Last time we have discussed, it is real. It's not imaginary. You can't imagine and say I want response within this much time. So I gave an example. Electronic system needs a millisecond, microsecond, etc. to respond, whereas mechanical system, because of its high mass and inertia, it requires in terms of seconds. So you have to be real. You cannot be imaginary. Just by imagining that electronic system gives within microsecond, you cannot say mechanical system should give in microseconds. Mechanical system can give only in seconds. So there we will keep the time limit in terms of seconds. So real time means time which is possible for the system. That varies from system to system. Based on that we have to set the limit. See here, a real time system takes inputs from the plan and sends control signal to the plan in the time limit determined by planned operational considerations. Planned operational consideration means whether it is mechanical system, whether it is electronic system, and this based on the planned operational considerations we fix a deadline or definite time limit. Within that definite time limit which is possible for the system should respond the output or give output. Such a system is called real-time system. So let us define once again. Real-time system is the system which produces correct responses within a definite time limit which is determined by planned operational considerations. Usually it takes inputs from the plant and sends control signal to the plant within that time limit. Usually almost all the systems will be having some control, either open loop or closed loop. So this is real-time system. Now there are classification based on many parameters. First I am classifying real-time system based on time constraints. Time constraint means we are giving a time deadline. No, within this much seconds or within this much microsecond, the system has to respond. That is a condition we are imposing. The real-time system means it should give an output within this much time. That time is decided by the physical nature of the system, whether it is mechanical or electronic. So after giving such a deadline, whether that failure to meet that deadline will have big effect or small effect, based on that, based on time constraints, we have two types of systems. One is hard real-time system. As the name indicates it's hard. Hard means every time when the system is operating, it should meet the guideline. Even once, only once, if the deadline is not met, collapse, total collapse. You understood? No. Every now and then, whenever the system is operating, the system should give output within the deadline. Must satisfy the deadlines on each and every occasion. Once or twice, if it doesn't happen, gone. For example, temperature control of hot air blower system. For your understanding, I'll give an example. Take an aircraft system, another example. In aircraft system, if some failure happens, can you say that, today if the control is not done, nothing we will not bother? No. All the passengers will die if the control is not taken. Whereas you take another system, ATM machine. ATM you insert. Today, if you insert and you don't get money, or its ATM machine doesn't work, will you have any big problem? No, you will go to another machine. Right? But every time if it is not functioning, you will go for strike. Understood? No. So hard real-time system is no chance. Once fails, you go for strike. You go for strike means you will not be there at all. For example, temperature control of hot air blower system. Once the deadline is not met, full it puts fire on the, not only on the system, also on the external environment, so that full damage occurs. Catastrophic effect occurs. So such a critical system, missile system, nuclear system, aircraft system, all these systems, you cannot take a risk. Every time the deadline should be met, and once if deadline is not met, gone. Such a system is called hard real-time system. Next is, as I told, ATM, soft real-time system. Soft real-time system is what? Almost every time, whenever it is possible, it should give the output within correct time. But once or twice, if it doesn't happen, it will not have a big effect. But every time if it goes, it is not meeting time deadline, you will throw that system, no? Will you keep? No. So like ATM, once you go and if it fails, then you will go to another ATM. So occasional failure to meet a deadline does not matter. That does not mean that every time it can fail. No. Assume that it works almost all the time, but once or twice if it fails, nothing will happen. No much effect will happen. Such a system is called soft real-time system. Now, let us see how the time constraints are met. So usually there are two types of systems, periodic systems and aperiodic systems or non-periodic systems. Periodic system is what? A task will repeat after every interval, t. 1, 0 if something happens, 1t the same thing repeats, 2t another repeats, 3t it repeats. There t is the period, you know that. So there are periodic things happening. You know that what is an example of a periodic system? Usually a feedback control system. What will happen? In each cycle, it will sense the output, calculate the error, sends a control signal, and in the next cycle again, it will measure the temperature or whatever may be the output, like temperature like output, again control action like that, no? So example is that. Then there are some systems aperiodic. Aperiodic means non-periodic. That means the system with some sort of indication. Example, water level in your tank, you keep a system. You don't have to monitor every time. When your tank of your house is filled, then motor has to get off. So that will happen. It will not be continuously monitoring whether it is filled or not. When that water reaches that top level, some resistance have some circuit there, resistance circuit we make so that continuous current flows, and this current will inform the your controller that level has been reached. So continuously we are not monitoring the level, but when the level reaches a particular value, control action takes place to switch off the motor. That is only once it is happening. When the switching off motor happens only when, or control of motor happens only when the level of the water has been reached. Such a system is called aperiodic system. So for hard real-time system as well as soft real-time systems, there will be periodic as well as aperiodic systems. So let us define this. TCI is what interval between I and I minus 1 cycles. That means the time interval between I and I minus 1 cycle. TEI is the response time to the ith occurrence of event E. Assume that your event occurs, something happens, the system will identify it and give a response and output, no? So time required for giving that output after reaching an event E is called TEI. This happens for which when event happens, so this happens, TEI, based on the event it happens. That means it is a periodic system we use this. TS is the desired periodic cyclic interval, this is for periodic system. T, the maximum permitted response time to event E. So how much time it is allowed for the system to respond. That means deadline. If it is not met, gone. TA is the average permitted response time. This is for average permitted time response. That means for a soft real-time systems, we will not be considering once if it fails, no problems. Average is measured in soft real-time. You remember, in hard real-time system, each and every time, the system should respond within correct deadline. So there is no question of taking average. Soft real-time system means what? Once it is passed, second it is good, third it is good, fourth may be failure. So now on an average, it should give good response. Correct deadline. Correct? No. So N is number of occurrence of event within particular time E. That means it is for periodic. And A is a small timing tolerance we give. That means deadline means if 5 microsecond if it happens, means it may reach 5.1 microsecond, we will tolerate. Such a tolerance limit. In all systems, very small tolerance limit will be there. So for a hard real-time systems, you remember whether it is periodic, for a hard real-time system, see, whether it is periodic or aperiodic, we consider each and every time. We don't consider average. No summation. Average is there when there is summation. Correct? So hard means every now and then means each time you see TC of I. That means each time it should meet, TS means maximum allowed time, no? Plus some tolerance limit. And if it is aperiodic event, you know that it's not happening within consecutive cycles. Only event occurs. So TE of I. T of I means time when the event occurs, what is the response? That should meet your deadline, TE. And whereas soft real-time system, we don't consider each individual meeting deadline. Take 10 or 15 times, so once it fails, no problem. That's why we always take average. Average means what? Take the sum and divide by n. That is called average. Taking sum and divide by average. So this is for a periodic means continuous TC of I. That means every I interval, it should meet, that average should meet TSR plus or minus A. Every now and then it need not meet. And for aperiodic, you know that it is based on the event. So 4 or 5 times event happens. That means 1 by n. Average of 5 or 6 events happening. So T of 5, that should be meeting the deadline, TE. Where n is, if for a periodic system, when you take the average, what is n? So total time if you consider divided by TS. What is meant by TS? That sampling time. So in a period T, if you take each TS sample one period means one sample means there will be total n is equal to T by TS of the samples. I hope you understood. Next, we classify the real-time systems based on how the system responds. So one is clock based. As the name indicates, you have studied in a digital system. Clock based means after every interval of time, the cyclic process or repetition happens. Usually, we keep a real-time clock inside the system, and based on that, the task happens. And here, usually the completion of operations within specified time depends on how many number of tasks we have or operations we have, and also the speed of the computer. Speed of computer is also very, very important there. That is set by means of a clock. And synchronization is done by adding a clock to a computer system. So all feedback control system, it is periodic and it is based on clock. At each occurrence of the clock, internal clock, it will sense the output, and if there is error, it takes control action and sends to the system. And next type of classification, event based. Event based means by means of an interrupt, only when something happens. That means liquid level indicator I told, no? In the tank we keep a top level indicator. Only when the water touches that indicator, it gives a signal that water has been filled. That time pump has to be off. So it is aperiodic, only once happening such things. And alarm conditions, temperature has crossed this much and initiate some actions and all. But actual control, feedback control system will not come under event based. It should be continuous. That means clock based. And the last one is interactive system. Interactive system, take for example ATM. ATM, how a person go and hits or touches the button, okay, it responds. Otherwise, no, it will not give money. And the time at which or time within which it gives money, whether it is decided based on whether a person, no. Will the ATM machine understand that the person is going for an urgent trip and the money has to be given fast? No. Or whether it knows that this person is very, very he is very free, I can give after 1 hour? No. The thing is that response happens when something happens from outside, like event. In event also, if some event happens from outside, the response happens. Like that, response happens when someone touches the button from outside, but the speed at which it does tasks like releasing money, asking this one, pin code, etc. It is not based on whether, it's not based on by checking whether person is free or in hurry. Instead, once the button is pressed, based on internal state of the computer, it may take 1 second, 1 second or 2 seconds, like that some internal settings will be there, and based on the computer, the response time or the response time, it is based not on the external. Your response when it happens, that is based on when the person touches the button of the ATM. But once it touches, releasing money, time required for releasing money, that is all not based on any reference to the external environment or person. Instead, it is programmed in the internal state of the computer. Usually the time constraint here will be average response time must not exceed, because you can't keep, doesn't mean that if the money is not released within 1 second, fire will not happen. So average response time is important there. So these are the classifications, 2 types of classification. One based on how you set the time constraint, second based on how the system responds, whether it is continuously responding like a feedback clock based. When something happens, like when liquid level has been reached, some action has to be taken, like event based. Interactive system, it looks like event based. When a person goes and touches, the response happens, but the time at which it responds doesn't depend on external environment, but it is programmed in the internal state of the system. But in you take the example of a other event based system. Event based system means what? When something happens, it gives the information, and the system should respond to meet the deadline based on the external system, because it is controlling the external system. So event based is like that. Interactive is not like that. Interactive system, when someone touches, it understands that it has to respond, but time at its response does not depend on who is pressing the button. Instead, it is pre-programmed in the computer. And IATM machine will not think whether he is in a hurry or not. So it is at internal state. But event based is not like that. Event is happening to safeguard or to protect outside system. So based on once the event happens, continuously to correct the outside system, it is giving the response. You understood, I hope. Thank you.